Today we're going to be looking at the properties of exponents, but we're going to be considering rational exponents as well, meaning that we have fractional exponents too, which is a thing. You can have exponents that are not integers or whole numbers. They can be fractions or even decimals. But we're just going to look at fractions today for our properties. So the first property that we want to look at is going to be the zero exponent property. Zero exponent property is pretty straightforward. There's not much to it. Zero exponent property says that if you raise anything to a power or an exponent with zero, then you will have, it will be equal to 1. So for example, x to the 0. So what describes our property here, x to the 0 is equal to 1. So our examples, of course, if we look at x to the 0 is equal to 1. It's the zero exponent property. 5 to the 0. If we raise 5 to the 0 power, that's also equal to 1. 2x to the 0. Well, that whole thing is being raised to the 0 power, so it's equal to 1. Very easy property of exponents. An exponent of 0, it will evaluate to 1. The next property is the negative exponent property. If a variable or base, by the way, when we talk about something with an exponent, for example, a to the b, the a is called the base and the b is called the exponent. Okay, so every variable or every part of a term will have a base and it will have an exponent. So if your base has a negative exponent, then you need to change whether the base is in the numerator or denominator. Okay, so whenever we're talking about exponential expressions that have exponents in them, we always, or terms that have exponents in them, we always split it into the numerator and denominator. Okay, now if you have a base that has a negative exponent, to change that exponent into a positive, you need to move the piece to the denominator. Okay, so x to the negative a, that's in the numerator, bring it to the denominator, and you now have x to the positive a. It's no longer negative, it's positive. Likewise, if you have the exponent in the base in the denominator and it has a negative exponent, you can change that to a positive exponent by moving it up into the numerator. So x to the negative a in the denominator, so 1 over x to the negative a, that would move the x to the negative a into the numerator, making it x to the a, positive a. There's nothing in the denominator, but we can assume that there's 1 in the denominator, but you don't have to write it if you have a denominator of 1. All right, so for example, x to the negative 4th power. The negative exponent, it's currently in the numerator, so if we want that exponent to be positive, we need to put it in the denominator. Since there's nothing in the numerator anymore, we'll put a 1 up here. Okay, if there's nothing in the numerator remaining, you will put a 1. So x to the negative 4 is the same as 1 over x to the positive 4. X to the negative 2/3, that's in the numerator. To make it positive, we need to put it in the denominator. So 1 over x to the positive 2/3 power. For number 3, 1 over x to the negative 1/4 power. Well, this is now in the denominator, but it has a negative exponent. So if I want to make it positive, I need to bring it up to the numerator. So x to the 1/4, now with a positive exponent, is in the numerator. I don't have anything left in the denominator because this came up, so there's nothing left in the denominator, so I'm not going to write anything in the denominator. So this simplifies to x to the 1/4. 2 over x to the negative third power. Okay, well, this is in the denominator, 2 is in the numerator. I do not want this to be negative, so I need to bring it up to the numerator. So in the numerator, I now have the 2. I still have the 2, but I also have x to the third. Since I brought the x to the negative 3 to the numerator, there's nothing left in the denominator, so you could just say 1, or you don't have to write anything at all. It's just 2x cubed. The next property is the product property. The product property says that if you are multiplying things that have the same base, then you can add the exponents. So x to the a times x to the b is x to the a plus b. This is nice because it means we can combine and only have one base. Okay, we should never have a base show up more than once in a problem. The bases can always combine if they're being multiplied together. So, for example, x to the second times x to the third, those can combine to give us x to the fifth. We just add 2 and 3 together. We look at the next one, we have 3x to the fourth times 2x to the 2/3. Well, anytime you have numbers, numbers can just get multiplied together. So like this 3 and this 2, those just multiply to make 6. So you can take care of those right away. However, by the way we got this 5 was by adding 2 and 3 together. That gave us x to the 5. But if you look, now we have fractions, we're going to have to add fractions. So we have x, and our numerator will be our exponent will be the 2 exponents added together, 4 plus 2/3. Okay, so I need to figure out what 4 plus 2/3 is. So that's 4 over 1 plus 2/3. I need to have a common denominator to add these, so I'll make a common denominator of 3. This already has a denominator of 3, so 12 over 3 plus 2 over 3, which is 14 over 3. So this should be 6x to the 14 over 3 power. We look at number 3, I actually have x, x, x. I have 3 of them multiplied together, 1/2, 5, 6, and 3. So if I want to combine these all into a single x, I need to add the exponents. So 1/2 plus 5/6 plus 3. Okay, so if I want to add these, I need to give them all a common denominator. So I'm doing 1/2 plus 5 over 6 plus 3 over 1. I need a common denominator of 6. So to make that here, I'll multiply by 3. And to make that here, I'll multiply by 6. So 3 over 6 plus 5 over 6 plus 18 over 6. So that's 18, 23, 26 over 6. So this becomes x to the 26 over 6 power. And that is the product property whenever you have bases multiplied together. The quotient property is similar. It applies to division. So if you have a base in the numerator and a base in the denominator, then you can combine them into a single base in the numerator by subtracting the exponents. Okay, so base in the numerator, base in the denominator becomes a single base in the numerator with the exponents subtracted, a minus b. Okay, so if you look at number 1, x in the numerator, x in the denominator, I can combine them into a single x that's in the numerator and just subtract 2 minus 4, which is negative 2. Unfortunately, you cannot leave it like this because we learned about the negative exponent property. Okay, so you cannot leave it as x to the negative 2. You have to change that to a positive exponent. Since it's in the numerator, it needs to go into the denominator to become positive. So 1 over x squared. So x squared over x to the fourth simplifies to 1 over x squared. For number 2, we have 6x to the third divided by 10x to the sixth. Now, 6 over 10, 6 divided by 10, that can just be simplified to 2 over 5. Sorry, 3 over 5. Because 2 goes into 6 and 2 goes into 10. 2 goes into 6 3 times, 2 goes into 10 5 times. So that's a 3 in the numerator, 5 in the denominator. Now, as far as the x's are concerned, x to the third over x to the sixth, those x's in the numerator and denominator can combine into a single x that's in the numerator, but I would have to subtract the exponents, 1/3 minus 1/6. Okay, so I'm going to do that over here, 1/3 minus 1 over 6. Need a common denominator of 6. So 2 over 6 minus 1 over 6, which is 1 over 6. So this becomes 3 times x to the 1/6 power over 5. Now, number 3, you'll notice I have negative exponents. I'm not actually going to, well, actually, yeah. So let me fix the negative exponents here. I don't have to do this right away. Actually, I'll do it at the end, actually. So this is an x in the numerator, x in the denominator. I'll combine those into a single x that's in the numerator, and I will subtract the exponents. So I have negative 1/2 minus negative 2/3. So I'm actually going to be adding that. That's going to be x to the negative 1/2 plus 2/3. Okay, so I just need to figure out what 1/2 plus 2/3 is. Negative 1/2 plus 2/3. Common denominator of 6. So this is negative 3 over 6 plus 4 over 6, which is 1 over 6. So this is x to the 1 over 6 power. You would not think that this simplifies to that, but it does. Power property. The power property is very easy. You just distribute the exponent on the outside. It gets multiplied by every exponent on the inside. So x to the third squared, that would be x to the 3 times 2. You just multiply those together, which is x to the 6. X to the 1/3 to the 1/2, you just multiply those together, x to the 1/3 times 1/2, which is x to the 1/6. However, when you have something like number 3, this is 2 to the first power and x to the second power. Both these exponents need to get multiplied by 3, okay? So that becomes 2 to the third power and x to the sixth power, which 2 to the third power is 8. So that's 8x to the sixth. That's actually an introduction to the next property, which is product of a power property, or product to a power property. Okay, so when you have a product inside parentheses and it's being raised to a power, then each of those on the inside get multiplied by that power on the outside. It goes to both of them, or more, all of them, however many bases there are inside. So this is x to the first and y to the first, so each of these first gets multiplied by a. So x to the a, y to the a. So if you look at number 1, x squared and y squared, this is a base of x, a base of y. They each have an exponent of 2. Both of those exponents of 2 get multiplied by 5. So that's x to the 10, y to the 10. For number 2, this is x to the third times y to the 1/2. And this is being raised to the 2/3 power. So each of these exponents get multiplied by 2/3. So that's x to the 1/3 times 2/3 times y to the 1/2 times 2/3. Okay, so if we multiply those together, that's x to the 2/9 power. 2 times 1 is 2, 3 times 3 is 9, and y to the 1/3 power. For number 2. Similarly, we also have the power of a quotient property. Power of a quotient works the same way, it's just you also have in the denominator a base. So we have a base in the numerator, a base in the denominator. The power on the outside needs to go to everything. It needs to go to every base in the numerator, every base in the denominator. So this becomes x to the a over y to the a. So for number 1, we have an x to the 1 in the numerator, a y to the second in the denominator, and each of those exponents get multiplied by 3. So x to the 3rd and y to the 6th, because 3 times 2 is 6. For number 2, very similar. We have x to the 2/3 in the numerator, y to the 1/2 in the denominator, and then we have a power of 3 over 4 on the outside. That power will get multiplied by all the powers on the inside. So on the top, we have x to the 2/3, and that's being multiplied by 3/4. And on the bottom, we have y to the 1/2, and that's being multiplied by 3/4. Okay, so that's x to the 2/4, or x to the 1/2. And this is y to the 3/8. Kind of like this. Quotient of a negative exponent property. So this has to do when you have a negative on the outside and you have numerator and denominator. Essentially, you can turn that negative on the outside into a positive just by flipping the numerator and denominator. So x over y to the negative a would be y over x to the positive a. You can just switch the entire numerator and denominator. So for example, x squared over y cubed raised to the negative 5th power, I could just swap them, y cubed over x squared, and make that to the positive 5th power. I would want to simplify this completely, okay, so which means no parentheses and only one base, one of each base. So I need to get rid of these parentheses. So this exponent of 5 will get multiplied by each of them. So that's y to the 15th over x to the 10th. Number 2, similar, except we have fractions. So same thing. I've got a negative exponent on the outside, so I can just flip. So y to the 3 over 4 comes to the top, and x to the 1/2 goes to the bottom, and now the 1/3 on the outside is positive. I do need to get rid of the parentheses, so each of these exponents on the inside of the parentheses will get multiplied by 1/3. So that's y to the 3/4, that's being multiplied by 1/3, and x to the 1/2, that 1/2 is being multiplied by 1/3. So those cancel, so I got y to the 1/4, and that is over x to the 1/6. Now we have a couple of examples that have basically all of the properties, and we want to simplify using all of the properties. One thing to keep in mind when you're using all of the properties, you have to satisfy 2 conditions for it to be simplified. Well, 3 actually. There can be no parentheses. There can be no negative exponents. And there can be only one of each base. Okay, so a lot of these you can tell that they're not simplified yet because they have parentheses, They have negative exponents, and for example, number 1, it has multiple of each base, okay? Like it has an x in the numerator, and it has an x in the denominator. That's 2 of the x base. You should only see x once. You should only see y once. You should only see z once, okay? So we need to simplify this so that we only see them once. So problem 1, x squared y cubed, and that is squared, and that's being multiplied by z to the 4th, and that's raised to the 5th, and it's over x cubed z, so that's z to the 1st, and that's being raised to the negative 2, and that's multiplied by y to the 5th, and that's squared. Okay, so first, let's get rid of all of these exponents, all of these parentheses using the power of a product property. So this 2 on the outside will get multiplied by both of these, so that becomes x to the 4th, y to the 6th. Same thing with the z, so that becomes z to the 20th, because it's got a 5 on the outside. And this is over x to the negative 6, because 3 times negative 2, z to the negative 2, because 1 times negative 2, and y to the 10th. Okay, now I can use the quotient property because there's a lot of bases that appear in the numerator and the denominator. For instance, x to the 4th and x to the negative 6th, x to the 4th in the numerator, x to the negative 6th in the denominator. I can combine those into a single x that's in the numerator by subtracting 4 and subtracting negative 6 from it. So 4 minus negative 6. I can do the same thing with the y's, because I have y to the 6th in the numerator and y to the 10th in the denominator. So I can combine them into a single y that's in the numerator by subtracting 6 minus 10. And same thing with the z's. I have z to the 20th in the numerator and z to the negative 2 in the denominator, so I can do 20 minus negative 2. Okay, so that's x to the 4 minus negative 6, so x to the 10, y to the 6 minus 10, that's negative 4, and z to the 20 minus negative 2, so that's 22. Now I'm almost done here. The only problem is that I'm not allowed to have negative exponents, but you'll notice I do not have any parentheses. I only have one x, I only have one y, I only have one z. The only thing I need to fix now is the negative exponent, y to the negative 4th. I can easily make that y a positive exponent by putting it in the denominator. The other 2 terms, the x and the z, can stay in the numerator, but the y comes down to the denominator and now becomes a positive 4. So this is my simplified expression here, x to the 10th, z to the 22nd over y to the 4th. Now let's see what it looks like with fractions. So we have x to the 1/2, y to the 2/3, and that is squared, and that's multiplied by x to the negative 1/2, y to the 2/3, and this is all over x to the 2/3 times x to the 4/5. Okay, this is quite a long one. Let's start by getting rid of the parentheses. Okay, so I got some parentheses here, so I can get rid of those by multiplying them by 2, each exponent by 2. So x to the 1/2, 1/2 times 2, so that's just x to the 1st, because 1/2 times 2 is 1. I also have y to the 4/3. 2/3 times 2 is 4/3. But I have x to the negative 1/2 here, and I have y to the 2/3 here. In the denominator, I have x to the 2/3, and I also have x to the 4/5. Now, I have a lot of x's to combine. I have a lot of y's to combine. Okay, so I have these 4 x's to combine. So I can combine all of these into a single x by adding the ones that are in the numerator, adding the exponents for the ones in the numerator, and subtracting the exponents for the ones in the denominator. So I'll add the ones in the numerator, so I have 1 plus negative 1/2. So those are added. And now I'll subtract the ones in the denominator, so minus 2/3 minus 4/5. So that's 1/1. For the y's, I'll do the same thing, but I don't have any in the denominator, so I just have y's in the numerator, so I'll just add the exponents of the ones in the numerator, so 4/3 plus 2/3. Okay, so I've got a lot of fractions being added together here. I'm going to need the common denominators for each of these. Let me try to add the ones I can so far. I'll add them 2 at a time. So 1 plus negative 1/2, that's just 1/2. 1/2 minus 2/3. Okay, so 1/2 minus 2/3. So that's 3/6 minus 4/6, which is negative 1/6. So 1/2 minus 2/3, negative 1/6, and negative 1/6 minus 4/5. Would need a common denominator of 30. So negative 5/30 minus 24/30. Negative 5 minus 24, so that's negative 29/30. So all of those add together to give me negative 29/30. And that is for the x's. For the y's, I have 4/3 plus 2/3, which is 6/3. And so this combines to make 6/3. And 6/3 is just 2. So that's just y squared. Okay, so my first problem got rid of the parentheses. My second thing I needed to do was combine all the bases into a single base of x. And now I just need to make sure there's not any negative exponents. So this term right here, this part, the y squared can stay in the numerator, but this x is going to have to go in the denominator and become positive. So y squared over x to the 29/30. And our last example here, number 3. We have x to the 1/2 y cubed over xy. And this is to the negative 1/2 power. And it's being multiplied by x squared. And that's also to the negative 1/2 power. Okay, this one's a little bit tricky. First of all, it does not need to be separated like this. This can be in the numerator of this one. Well, actually, not quite. First of all, let me try to simplify each of them separately a little bit. Okay, so this one, negative exponent on the outside means I can just flip the top and bottom. So xy in the top now, x to the 1/2 y cubed in the bottom, and now it's got a positive exponent of 1/2. This is being multiplied by x squared to the negative 1/2. I'll just multiply that 2 by 1/2, so this will be multiplied by x to the negative 1. All right, let me get rid of this exponent here. So all of these exponents on the inside, this is x to the first, y to the first, x to the 1/2, y to the third. You can multiply the 1/2 to each of these, or you can simplify the inside first. Since we have fractions, you might want to simplify the inside first, but it is really up to you. Okay, so maybe I'll simplify the inside first. And I'll just multiply them all by 1/2. So this gets multiplied by 1/2. All of these exponents get multiplied by 1/2. So that's x to the 1/2, y to the 1/2 over x to the 1/4, y to the 3/2, and that's multiplied by x to the negative 1. Now, if you remember x to the negative 1, that's the same thing as 1 over x to the 1. It'd be a positive 1 in the denominator. Okay, well, if you remember how to I don't need these parentheses here anymore. If you remember how to multiply fractions, I mean, we just did it 100 times. You just multiply the numerators and the denominator. So these are just multiplied together, and you don't have to write the 1. So I have in the numerator x to the 1/2, y to the 1/2. And in the denominator, I have x to the 1/4, y to the 3/2, and x to the 1st. So now I can combine the x's and combine the y's into single bases. So I'll combine all the x's into a single base in the numerator by adding the exponents that are in the numerator and subtracting the ones in the denominator. So 1/2 minus 1/4 minus 1. That takes care of this, this, and this. And then I'll do the y's as well. So 1/2 minus 3 over 2. That takes care of those. So everything's accounted for right here. I just need to do the fractions here, and then I will be solid. Okay, so 1/2 minus 1/4 minus 1. Okay, so I will need a common denominator of 4. So that's 2 over 4 minus 1 over 4 minus 4 over 4. So 2 minus 1 minus 4. 2 minus 1 is 1, and 1 minus 4 is negative 3. So this is x to the negative 3 over 4. Y, I have 1/2 minus 3 over 2. They already have a common denominator, so that gives me negative 2 over 2, which is just negative 1. All right, parentheses are gone. They've all been combined into the same base. We have one x and one y. We just now need to get rid of the negative exponents. These are both currently in the numerator. Since they're both negative exponents, they are both going to go to the denominator to make them positive. So x to the 3/4 and y to the 1st. Since there's nothing left in the numerator, we'll put a 1. And we don't need this 1 on the y, so I'll just get rid of that. So this is the simplified version for this complicated problem for number 3. This is how we would simplify it.